Hello. Hi, Kiran.
Good evening.
Yeah, good evening. Am I audible and is my screen visible to you? Okay. So we'll wait for a couple of more minutes and then after we'll start.
Okay.
Meanwhile, if you have any questions, then you can ask meanwhile. Hi, Shreya.
Hello, am I
Hi.
audible?
Hi, you are audible.
Hello, sir. Good evening.
Good evening. So we'll just wait for 2-3 more minutes and then after we'll start.
Okay, sir.
I think we can start now. So, hello everyone. My name is Hiren Solanki, a PhD scholar from Department of Art Science at IIT Gandhinagar, and I will be conducting this problem-solving session of course Geographical Information System from NPTEL. And I welcome you all for week 10, where we will discuss about the different types of derivatives of DEM, how to calculate them, and some kind of questions on them. So as we proceed in the previous classes, in this class also, first we'll take a quiz. This might be a longer quiz compared to the earlier quiz which we had because it has a lot of concepts and conceptual understanding is required to grasp the concept. And then after we will explore some of the data sets if time permits afterward. And then we'll see some of the activity how to calculate the different kind of DEM derivatives inside the QGIS framework. So with this, let's start today's session. Uh, so let me go to the, okay, I think, is it visible, my screen?
Yes, sir.
Okay, that's great. So let's get started with the question number 1. The first question is, aspect is measured in which of the following planes? So the answer is vertical plane, inclined plane, horizontal plane, and oblique plane.
Option C, sir.
Yes.
Horizontal plane.
Exactly. So when we calculate the aspect, it is calculated in a horizontal plane, whereas when we consider slope, then it is considered in which plane?
Sorry, sir, can you repeat your question?
Yes, so instead of aspect, if I have slope here, slope is measured in which of the following planes, then what might be the answer?
Vertical plane.
Exactly. So slope corresponds to vertical plane, whereas aspect corresponds to horizontal plane. Okay. The next question is, in a raster-based aspect calculations, flat areas with no downslope directions are assigned which value? 0, 90, 360, or -1?
-1.
Exactly. So aspect varies from 0 to 360 degree, and if it is a downslope or flat area, then it is like given as a value of -1. Next question is, which of the following correctly describes the aspect angle? Uh, yeah, Shreya, can you turn off your mic? Yeah, thank you. Which of the following correctly describes the aspect angle range for non-flat areas? -80 degree, 180 degree to +180 degree, 0 to 180 degree, 0 to 360 degree, or -90 degree to +90 degree.
0 to 360 degree.
Yes. So aspect is with angle with respect to the north direction, and that's why it's considered as a 0 to 360 degree. Okay. Next question is, the formula used to calculate aspect in a planar method. Okay, the formula used to calculate aspect in the planar method is, so aspect 57.29578, 8 dz by dx and dz by dy. So which one is the correct here? So the first one, dz by dx, is positive and second one is negative. In the second one, first is dz by dy and another one is a negative. Third one, dz by dy divided by dz by dx, and the fourth one is dz by dx divided by dz by dy.
It's B, option B.
Yes, so correct answer here is option number B. Okay, the next question is, which of the following statements about the 3 cross 3 kernel used in aspect calculation is true? Cells at the boundary of raster gets valid aspect values. At least 5 valid neighboring cells are required for the computation of aspect. The output borders cell 1 pixel thick will have no data values, and the kernel uses weighted averaging only for cardinal directions.
Uh, B and C.
B and C. Okay, so C is
B
right.
also. B also.
C is right, but for B, is
At
it
least
5?
7.
Yeah, it is 7, so that is false. So at least we need 7 valid neighborhood pixels for the computation. So option B is wrong. Cells at boundary of the raster get valid aspect value, so that is wrong because cells at boundary will get no data values, which is given in the option number C. And the kernel uses weighted averaging only over the cardinal direction. That is wrong because we use all the direction, not just north, south, east, west. So not the 4 direction, but we use the diagonal direction also for the calculation of slope or aspect. So that's why the last one is also incorrect. And here the cardinal direction means the main 4 directions. So correct answer here is option number C. Next question is, identify the true statement regarding slope versus aspect. Both slope and aspect are measured in vertical plane. Slope is measured in horizontal plane while aspect in vertical plane. Slope is measured in vertical plane while aspect in horizontal plane. Both slope and aspects are measured in horizontal plane.
Option C, sir.
Yes, the slope is in vertical and aspect in horizontal. Next question is, in the geodesic method for aspect computation, the coordinate system used is topocentric Cartesian system, Earth-centered, Earth-fixed ECEF 3D Cartesian system, universal transverse Mercator system, local polar coordinate system.
Option B, sir.
Yes, so Earth-centered, Earth-fixed 3D Cartesian system. Which of the following is primary difference between planar and geodesic aspect computation methods? Planar method uses 5 cross 5 kernel, while geodesic uses 3 by 3 kernel. Planar works on a projected flat plane, while geodesic considers Earth ellipsoidal shape. Planar is more accurate than geodesic for larger scale studies, and geodesic assign -1 to flat areas, planar does not.
Is it weak?
E Planar works on projected, yeah, that is correct. So first one, planar and geodesic both use 3 by 3, that's why that is incorrect. Uh, and when we talk about the accuracy, geodesic is more accurate compared to the planar because we see underestimation of areas in a planar work compared to the geodesic one. That's why the option C is also wrong. And talking about the fourth one, so that is like both the method will assign -1 if we have flatter areas. Next question is, in the geodesic aspect method, the plan fitted around each processing cell uses which mathematical technique? Newton-Raphson iteration, Fourier transformation, least square method, or Kriging interpolation?
Option C, sir.
Yes, so the correct answer here is least square estimation. Next question is, plane curvature is perpendicular to which of the following? The direction of minimum slope, the direction of maximum slope, the north direction, and the aspect direction of the neighboring cell.
Option 2, sir. B.
Yes, so the plan curvature is perpendicular to the direction of maximum slope. And then this plan curvature we calculate using the contour lines which are passing at a given point. Whereas when we consider a foam curvature or the ones we will learn further, that is calculated using the vertically. Okay, next. Which curvature type primarily influence the acceleration and deceleration of water flow across a surface? Plan curvature, profile curvature, general curvature, and tangential curvature.
Option B, sir.
Yes, so that is a profile curvature. When we talk about plan curvature, it will show us whether the water will converge or diverge. Whereas profile curvature tells us the acceleration and deceleration of flow. And combining both will give us the total idea about how water will flow, where it will erode the surface, and where it will do the deposition of sediments. Next question is, in profile curvature, a negative value indicates concave surface in which erosion prevails, convex surface, deposition prevails, convex surface, erosion prevails, or linear surface where there is a no change in flow.
Option
B.
C.
Yes, the correct answer here is option C, but I think we will look this concept for more details in slides as well, so that you get some idea. I think it's enough. Lecture number 5. Mm, yeah, so this is the lecture on curvature. And what do we have in the question was about the profile curvature. So you can see first of all the plan curvature. So plan curvature, if we consider, that is in the perpendicular direction of the maximum slope, and the second thing is it is a described as a curvature of the hypothetical contour line. So basically it's a horizontal direction, if we can say that. And then this is positive for the sail, which is having concave contours, such as shown in uh, red. Uh, and then, sorry, the plan curvature is positive for the sail with concave contours. So it's written wrong, shown wrong here. And negative for the sail with the convex. Plan curvature can be used to differentiate between ridge and valleys. Then if this plan curvature, if it is positive, then if basically it's a convex, then it will, what will happen, that it will, as you can see here, it will diverge, here it will converge, and here it will just go. Similarly, when we consider the profile curvature, then this profile curvature is the curvature along like this. So in the direction of the steepest slope, in the direction, not in the perpendicular direction. It is the direction of the steepest slope. And here also in the top portion, we can see if it is convex, then it's a negative. And then if it is a concave, then it's a positive. And here, if wherever it is a convex, it will erode the surface. It will happen, the erosion will prevail. And in the location of concave, the deposition will prevail. So as you can see here, if water will go from the surface, it will try to erode from the surface, and when it is having like this, it will try to deposit that, so that making the overall surface. And this is like, if it is convex, then it will go, the surface is upwardly convex, as you can see here, and the flow will decelerate, means it will decelerate the flow, velocity will go decrease. Whereas in B, it will increase, upwardly concave at the sail, and the flow will be accelerated. Then the value 0 indicates the surface is linear. Okay, so based on that, here for profile curvature, negative value is a convex and erosion prevails. Okay, so the next question is the topographic position index, which is known as a TPI, is defined as the ratio of surface area to planimetric area of a cell, the difference between a cell's elevation and the mean elevation of its neighborhood, The sum of absolute elevation differences between a cell and its 8 neighbors. The standard deviation of slope values within a watershed.
Option B, sir.
Yes, so it's a difference between a cell's elevation and the mean elevation of the neighborhood 8 pixels. So option number B is correct. Next question is, which of the following correctly distinguish between the TRI from TPI? So TRI is topographical ruggedness index or roughness index, and TPI is topographical position index. TRI uses mean of absolute differences, while TPI uses differences from mean of surrounding cells. TRI uses difference from mean, whereas TPI uses maximum minus minimum. TRI and TPI are mathematically identical. TPI uses absolute differences. TRI uses differences from neighborhood.
Option D, sir.
I think option A.
Okay, so here the correct answer is option number A. So the definition of TRI is a mean of absolute difference, as TPI is a difference from the surrounding cell. So to look into detail, I think you can go and check out in the slides so that you can get the clarity. Mhm. So I think it's a lecture. So TPI is a basis of the classification system and is simply the difference between a cell elevation value and the average elevation of the neighborhood around that cell. So elevation minus, you can do the average of neighboring each cell and then take a difference between these two. The degree to which higher or lower. So basically the cell is above or below, higher or lower, corresponding to the neighboring pixels. So it will give us the localized depression or localized hill type of cells. So plus the slope of the cell and can be used to classify cell into slope position. The position value mean the sense cell is higher than its surrounding, while negative means cell is lower corresponding to their surrounding. If it is significantly higher than surrounding neighbors, then it is likely to be at or near the top of the hill or ridge. And significantly low value suggests the cell is at near bottom, or you can say it well. So if you can see, if higher the positive number, you can go towards the hill area or ridge areas. Whereas if TPI value is very less or negative, then you will go towards valley and canyon bottom. And if it is zero, it means that either the area is flat or a mid slope area. Mid slope area means the like nearby pixels are averaging out. So averaging out the given pixel. So it's a mid slope area. Cell slope can be used to distinguish the two. Like basically the cell slope. Like here, cell slope can be used to distinguish two means whether you have flat area or to a mid slope area, so that we can find out using the slope. If the slope at that location is also zero, then the area might be flat. But if there is some small uh, slope is there, but the TPI is zero, then we can consider it as a mid slope areas. And this is a very localized phenomena depending on our scale which we are considering. So if we are considering a very less amount of like size of pixel is let's say 10 meter by 10 meter, then in this case, if you can see here, then TPI will be zero because the nearby cells have similar elevations. But similarly, if we increase the resolution, instead of 10 meter by 10 meter, if we increase to 30 meter by 30 meter, then you can say it will capture the valley also. So compared to this valley, the given location is at above. So it will show some kind of ridge and our TPI will be greater than zero. On the similar case, if we extend the area more, now after 30 meter, if we go to 100 meter by 100 meter pixel, then you can see the TPI will become less than zero. It means here some higher areas are coming. So compared to that, this point is at lower elevation. So in this respect, the TPI is very much scale dependent. It depends on what resolution or spatial resolution of DEM we are using. Okay, so that is a thing, and I think TRI, if you see, it will be so TRI provides a rapid objective measurement of terrain heterogeneity. It's calculated by the largest intercell difference of the central pixel and its surrounding scale. So here, okay, it's a largest intercell difference. So instead of mean, we can say it is a largest intercell difference. So in question, we can say TRA uses the not mean, but absolute difference, maximum of absolute difference between the like 8 pixels, neighborhood pixels, to define it more correctly. Okay, I think there is no doubt between these two now. Let's move to the next question. A topographic profile along a drainage line, which is an arbitrary line, can only be reliably created using survey topographic sheet with contour interpolation, aerial photograph stereoscopic analysis alone, GIS platform with digital elevation models, and field GPS traversing with manual plotting.
Option C, sir.
Yes. So here, I mean, if you know, if we have GPS also, then also we can develop this kind of cross-sectional profile. But the problem is, they are saying along the drainage line. Along the drainage line means it's a kind of river or any other drainage network. So we cannot go and do the survey along it when the water is there. So it's like more or less if we have DEM, then it will be good to do. Okay. So now there will be a couple of questions where there will be two statements and you have to tell which of the following statements is true and false. The first one is in aspect calculation, a south-facing slope on the northern edge of Missouri towards the Indo-Gangetic Plains is described as having a northerly aspect. Statement number 2. Aspect identifies the downslope direction of maximum rate of change in value from each cell to its neighbor. So which one is true and which one is false, or either both are true or both are false?
Option A is false, but the statement 2 is true.
Okay, so now if the statement is false, then what you can change to make it correct?
If it's a south-facing slope, so it should be in southerly aspect.
Exactly, exactly. So it should be a southerly aspect because it's a south facing slope. So obviously it's a southern side aspect value. So the option statement 1 is false and second one is true. Okay. The next question is the surface area of a sloping cell is always greater than its planimetric area. Statement number 2. Planimetric area is calculated by dividing surface area by the cosine of the slope angle. Anyone? So let's talk about the first statement. Is it right or wrong? True or false?
It is true.
Statement 1
True.
is true.
It is true. Surface area of a sloping cell is greater than the planimetric area. So that is true. Talking about the second one.
It is false.
Yeah, it's false. So what should we do to make it correct? Our answer is true and false, option number C. But now what can we do to make the statement number 2 correct?
Uh, Surface area equals to planimetric area divided by cosine of the slope angle.
Exactly. So the statement is should be opposite, that surface area is calculated by dividing the planimetric area by the cosine of a slope angle. So there is an interchange of words which we have to do. Okay. Next question. The statement number one is is uh, plan curvature is positive for cells with convex contours. And the statement number two, profile curvature is parallel to the direction of maximum slope.
Option B, sir.
Okay. So plan curvature is a positive for cells with. Okay, I think we'll just check it once. If there is a issue in the slide in the current, yeah, plan curvature. So plan curvature is positive. So plan curvature is positive for concave contours. Okay, so here it's a green one is concave, but they have written it as a convex. Sorry, it's right. Convex only, and this is concave. So I think I will get a more clarity on this, which one is right. So plan curvature is positive for cell with concave. I think we'll have to rectify this thing because both shows a different meaning, so might create issues for you. But generally, if we see, then this should have positive and this should have negative. So convex should be positive and concave should be negative. So going through figure, so plan curvature is a positive for convex. So positive for convex. So in that case, the option number B should write. But here, like I have considered the theoretical definition, so it should be false and true. But yeah, I think I will go to the definition given in the image. Okay, so next is the planimetric to surface area ratio is largely scale dependent. And in vector-based GIS, area calculation uses the plan geometry equations.
Option D. Yeah, sorry, option A.
Okay, the second one is true because when we consider the vector data, it do not have 3D positioning, so it will consider the planimetric area only. So option B is right. But when talking about statement number one, planimetric to surface area ratio is largely scale dependent. So scale dependent means like it's kind of TPI, which we have seen earlier. That if it is giving a localized variation, then it is a scale dependent. Depending on what kind of DEM resolution we will use, according to that it will change. But here we are just talking about area. It doesn't matter which resolution we are using, whether you will consider 10-meter resolution or 15-meter resolution or 30 or 100-meter resolution. The area will remain same. Similarly, the surface has similar angle corresponding to surface. So basically, if we calculate the cosine, the theta will be same. So this ratio is scale independent because we are considering about area. If we are considering about the localized indices such as TPI or TRI, then it will be scale dependent. But here, if we are just considering the ratios, and that also for area, that's why it will become scale independent. Is it clear? So the option number one is false and the second one is true. If you have any doubt, please unmute and ask. Okay. Next question is TPI values near zero always indicates valley bottom. Second statement, sail slope information can help distinguish flat areas from mid-slope areas when TPI is equal to zero.
Option C, sir.
Option C. Okay. So first of all, TPI, when we just discussed a few minutes before, zero means what? The difference between the surrounding cell is not that much. So it will show the flat area or mid-slope areas. If it is negative or towards more negative, then it will show the valley bottoms. So here it's written that nearly zero. It means it will show the flat or mid-slope areas. Option 1 is false. Second one
Option D,
is,
sir.
yeah, second one is cell slope information can help to distinguish flat areas from mid-slope areas when TPI is equal to 0. So that is a true, because what I told you that when it is TPI is near to 0, there will be two possibility. Either it can be flat surface or it can be a mid-slope area. So when it will be a flat surface, if all the nearby pixels have similar values, then it will be a flat areas. But if the like one side of pixel have upper values, then one side also smaller values. So overall, if we see, the TPI will become 0. Like if it is like going this gentle slope, then in that case TPI will go 0. But if we consider its slope, then it will be a mid slope area. So that statement number 2 is correct. First one is false and second one is true. So next question is, the geodesic aspect method produces more accurate results than the planar method. Statement number 2, the geodesic method is unaffected by the map projection of the input dataset.
Option yes, sir.
Okay, so the first one is true. Second one, because when we consider the geodetic, it will consider the 3D aspect. And if we are considering 3D aspect, then it's always like a good as compared to the planar. So that will be more accurate. The first one is true. The second one, geodesic method is unaffected by the map projection of the input data set. So that is also true, because projection is means how we are, which unit we are using, by basically degree to minute, degree to meter conversion and all. So they will not affect the actual surface, because uh, like because we are considering 3D aspect only, so it will not affect the projection. So that is uh, true. It will remain unaffected. And the first one is true. So both are true. Next one is, in a cut and fill analysis, positive volume values indicates areas where material has to be filled. For cut and fill analysis, both input rasters must have a common origin, same rows and columns, and same cell size.
Option B, sir.
Yes. So negative value will show the filling volume, and positive value will show the cutting. So the option A, the first statement is false, and second one is true. It should both should have same origin, same data. Like all the pixels should align with each other. Okay. So the next question is, uh, standard or general or total curvature combines both profile and planform curvature. Statement number 2. In total curvature, a positive value indicates valleys while a negative values indicates peaks.
Option B, sir.
Option B. Okay. So going to the next, I think we've already seen that thing in PPT, so I will not discuss more on that. Yeah, next question is, south-facing slopes in Himalayan terrain receive maximum solar radiation and are most vulnerable to landslides. The next question is, next statement is, north-facing slopes are preferred for sky runs because they receive more sunshine throughout the day.
Option D, sir.
Option D. Yes, the first one is true and the second one is false. So what we can do to make it true?
Less sunshine, sir.
Yes, so if instead of word more, it should be less sunshine throughout the day. And it will not, snow will not melt, and because of that, we use it for skyruns. Yeah. Next, statement number one. In TPI classification, a coarser DEM resolution results in a larger range of TPI values, such as -650 to +650. Statement number two. TPI is scale independent and gives the same results regardless of the DEM resolution.
Option D.
Option D. Okay, the second one is false that we have already discussed. But what about the first one?
True.
Yeah, the first one is true because our DEM is a coarser resolution, so it can have more variation in the elevation. Sometimes, like if the hill is there and then suddenly the valley is there, and both are captured within just 1 or 2 pixels, it will give a more amount of variation within the corresponding cells or nearby cells, and that's why we'll get more larger values. So the statement one is true and the second one is false. So answer will be B. So now these are the some of the multiple correct options. So more than one can be correct here. Which of the following are valid application of aspect maps? Finding north-facing slopes for sky-run suitability, calculating solar illumination for photovoltaic development, determining the volume of earthwork for road construction, identifying the snowmelt-prone south-facing slopes, locating flat lane for emergency aircraft landing.
Options 1, 4, 5, sir.
1,
4, 5.
4, 5. Okay, anything else?
I think two.
Yes. So as we discussed, like the uh, cells facing solar southern aspect will receive more sunlight depending on where you are. Okay, so option 1, 2, 4, 5 are correct. And the determining the volume of earthwork, that is a cut and fill analysis application, not the aspect. Which of the following correctly describes property of a 3 by 3 moving kernel used in aspect calculation? It requires at least 7 valid neighboring cells for computation. It produces no data along one cell thick border of the output raster. It uses the 5 cross 5 neighborhood for increased accuracy. If the center cell is no data, the output is also no data. And it visits every cell in the input raster sequentially.
One, 2, 4, 5, sir.
So 1 is correct, 2 is correct. Instead of 5 by 4, it should be 3 cross 3. That is also correct. And this one is also correct. Okay, great. Next one is, which of the following is not an application of curvature map in GIS terrain analysis? Identify soil erosion patterns, detecting geological lineament and fault geomorphology, calculating cut and fill volume for road alignment, mapping glacier accumulation and dissipation zones.
1, 2, 4, sir.
Not, which is not application.
I think option C.
Yes. So what you answered, it's a application. Here the question is written not, is not an application. Okay, so please consider on those words whether it's written not or not written not. Okay, so Mostly you will do this kind of mistakes during your exams. Yeah, the next one is which of the following statements about the surface area versus planimetric area are incorrect? Surface area always equals planimetric area for flat terrains. Surface area is planimetric area divided by cosine of slope. Planimetric area always overestimate actual ground area on slope. And a 45-degree slope with 100 by 100 meter by 100 meter planimetric cell has a surface area of approximately 141.4 meter square. So we'll go one by one. Surface area always equals planimetric area for flat terrain. Is it true or false?
It's true.
Yeah, it's true. Second one is surface area is equal to planimetric area divided by cos of slope.
True.
So that is also true. So these two cannot be our answer. Planimetric area always overestimates actual ground area on slope.
Hey,
False.
I think it's
False.
false.
It should be underestimate. So this one is false. A 45-degree slope with 100 meter or 100 meter by planimetric area cell has a surface area of approximately 141.4 meter square. Now see,
False.
yeah, it's false because you just do, if the size is 100 by 100 meter, if you just multiply it also, it should be like 100 into 100. It should have 4 zeros. And here just 3 numbers are there, 141. So like from that only you can say that it is wrong. Okay. The next one is which of the following indices or derivatives cannot be derived from a DEM? Topographic position index, terrain ruggedness index, plan curvature, or normalized difference vegetation index.
Option B.
Yes, so that can be calculated using the near infrared and red band from remote sensing data. So in the context of geodesic coordinate transformation used in the aspect computation, which are correct? So first and second are the x and y z formulas for x and z to convert from geodesic to planimetric basically, and the other two are definition of the terms.
1 to 4, sir.
1, 2, and 4. And why the third one is incorrect?
It is major axis.
Exactly. Next is which of the following correctly describes the topographic position index classification system? Positive TPI values typically indicate ridge roof or ridge tops or hilltops. Negative TPI values typically indicates valley bottom. TPI near zero with shallow slope indicate a flatter area. And TPI values are completely independent of DEM's partial resolution.
1 to 3,
One,
sir.
two, three.
Okay, so the first, second, and three. Then it should be dependent. Next question. Which of the following is not a valid application of topographic profiles or cross sections generated from DEMs? Generating geological cross sections, identifying rapids and falls for small hydropower site feasibility, performing cuts and fill volume estimation for road alignment, calculating NDVI from multispectral imagery.
Option D, sir.
Yes. Next question is which of the following statement or statements about the aspect conversion rule from the calculated value to compass direction are correct? If calculated aspect is less than 0, then cell is equal to 90 plus aspect. If calculated aspect is greater than 90, then cell equal to 360 minus aspect plus 90. If calculated aspect is equal to 0, the area is flat and assigned a -1. If aspect is between 0 to 90, then the cell is equal to 90 plus aspect.
Option B and D.
Option B is right, but when you think about D, it should be 90 minus aspect, because in the,
99%.
yeah, and if you think about option C, then in that case, if aspect is 0, then it doesn't mean that it is a flat. Okay, so if it is a flat, then it will directly assign -1. 0 means it's a northerly aspect. So that's why it is a also false. And the first one should be 90 minus aspect. Here also 90 minus aspect. And here it should be northerly aspect. Next question is, which of the following incorrectly describe differences between the Horn method and the Zivangbergen and Thorne method for aspect calculation? The two methods can produce different aspect values for the same cell. Horn method is default in most GIS software like ArcGIS. Thorne and Horn methods always gives lower aspect value than Horn. Both method uses 3 by 3 kernel neighborhood.
Option C, sir.
Exactly. So it's not always gives less values or lower values. It depends where you are, in which kind of aspect it has. Okay, so now the next question is numerical. Using the planar aspect algorithm, the rate of change in direction x for center cell E is calculated as dz by dx, which is c plus 2fi weight 1 minus a plus 2d plus g into weight 2 divided by 8. So given C85, F85, I84, A101, D101, G101, and all of C, F, I are valid, all A, D, G are valid, then what is dz by dx? So do the calculation and also calculate dy by dx, dz by dy also. So 85 plus 2 into 85 plus 84 into weights are 4 minus 101 plus 2 into 101 plus 101 into 4 divided by 8.
It's minus 8.125.
Okay. Okay, so great. So I think we'll check it out in a slide. So this is the conversion which we're talking about. Aspect is less than 0, it should be 90 minus aspect. Then if it is greater than 0, 36 minus aspect plus 90, and in the other condition, which is from 0 to 90, it should be 90 minus aspect. So these are the calculations. So here these weights are given as, if any one of it has no data, then it will be considered as a zero weight for that. Here all have data, so 1, here 2, and here 1, so total 4. Here also similar. And when you are considering dz by dx, you have to take adg and cfi. And when you considering the dz by dy, you have to take abc and ghi. So here similarly, so this minus this, and here this minus this. And then you put into this formula and you can calculate the aspect, which is dz by dy, comma, minus dz by dx, 8 and 2. So here it's a calculation. So these are the cells which we have. Why this kind of calculations are necessary is because when you see, if you consider the middle pixel and then you see the elevation differences here, highest difference is between 92 and how much, 101 and 84. Like if we consider the uh, 92 and 102, the difference is around roughly 9. Whereas if we consider the 85, 84, okay, then it's a 8. So when we consider 101, there will be 3 point, okay, which are similar. And then it can, like when we consider slope, where to consider slope? Because if we consider the maximum differentiation between the pixels, then 3 are having the similar values, like difference is similar for all the 3. And that's why we use this combination, considering all the pixels on an average slope or on an average aspect, rather than focusing on just one value from the given pixel. So here the correct answer is minus 8.125. And similarly, if we calculate dz by dy, then it's a minus 0.375. Similarly, now going forward, for this question only, you got dz by dx as a minus 8.125 and dz by dy minus 0.35. Now you have to calculate the row aspect value before the compass conversion. So for that you will use the formula. This one, aspect is equal to 57.29, 8 and 2. So you will use this. Now if we see, so this function is 8 and 2, y comma x returns the angle of theta between the positive x-axis and the ray of origin from the point x comma y confined between minus pi to pi. So I think we'll not go into that calculation, but if you will put this value here, you will get minus 2.64, and this value is less than 90 degree. So the condition is the first condition, that it should go 90 minus aspect. So this 90 minus minus 2.64, and then it will become 92.64. So here in this question, minus 2.64 should be answered. And then after, if we consider minus 2.65, then 90 minus 2.65 will do, we'll get the 92.64. So then after, as we got 92.64, this 92.64, now someone asks you that it is in which direction of slope is in which direction. So you can say that 92.64, it means it should be in this eastern direction. Okay, so here you can see the like overall slope is in the southern direction. Okay, any doubt, anyone? Someone has raised hand or what? Okay, okay, huh. So this is how the calculation is being done. So this is in the easterly direction. Okay, the next question is, a grid cell has a planimetric area of 1 hectare now and lies on a 45-degree slope. What should be its surface area? So what will be the formula to convert planimetric area to surface area? It should be planimetric area divided by cosine of 45 degree. So do that and let me know what should be your answer.
Option C.
Yes. So option number C. So please keep a mind of conversion also, because if someone has written just 1 hectare and I have given in meter square, what does it mean? But sometimes it is not given. So you should consider in mind that 1 hectare is equal to 10,000 meters square. Next question is, a location has a 20% slope. What is the slope angle in degree? So tan theta is slope in percentage divided by 100. So you will put slope there, 20 divided by 100. So it will become,
11.31.
yes. So then take the tan inverse. Next question is, using the results from question 40, 11.31. The surface area factor of course 11.31 is 0.9806. For a 5 hectare grid cell at 20% slope, what will be its surface area? So convert that planimetric area to surface area using the cosine of 11.31. So 5 hectare divided by 0.98. So it will be very clear that if from option if you see, you can clearly say what should be answered. It should be greater than 5. So option A is wrong, B is wrong, and then we have to just see C or D.
C, sir.
Next, in aspect calculation using the planar algorithm, the constant multiplier of 57.29578 represents pi 180 divided by pi, a conversion factor for radius radian to degrees, 1 by 10 1 degree, or the Earth's eccentricity factor.
Option B, sir.
Yes. Next is, a civil engineer is designing an elevated expressway through a Himalayan valley. The existing terrain has elevation between 340 meter to 2200 meter. The required road level is set at 800 meter. Which GIS operation should the engineer use to estimate the volume of earthwork required? Slope analysis, viewshed analysis, cut and fill analysis, or TPI classification?
Option C, sir.
Yes, cut and fill analysis. Uh, Next question is, a geologist wants to identify a slope in Himalayan region which will experience snow melt earlier this summer season. Which DEM derivative should be primarily used for this analysis? Profile curvature map, terrain ruggedness index, aspect map, or topographic position index?
Option C, sir.
Yes, so aspect map identifying south facing slopes. A minute. Charge. Hmm. Yeah. The next question is a hydropower developer needs to quickly assess the potential small runoff river hydropower sites along the river without visiting the field. Which GIS tool or operation would best serve as a first level screening tool?
Option B, sir.
Yes. Next question is a geomorphologist is analyzing landform types in a watershed at two scales using the TPI. At 500-meter resolution, a particular cells show TPI of 180°, which is strongly positive. At the same time, at a 2000-meter resolution, the same cell shows TPI of -420, which is strongly negative. What is the most likely geomorphic interpretation of this study? The cell is valley bottom at both scale. The cell represents local ridge within a larger regional valley. The cell is a flat plane at both scale. The cell is a mid-slope position at both scale.
Option B, sir.
Yeah, it's true. Next is an ecologist wants to map habitat zone in a mountainous national park based on the terrain characteristics. She needs to differentiate between ridge top, valleys, and open slopes and flat terrains. Which approach is most suitable here? Single-scale TPI classification using landform characteristics, two-scale TPI analysis, small and larger neighborhood, combined with slope, profile curvature analysis alone, aspect map combined with hillshade.
Option B.
Yes, that's true. A project team calculated surface area using planimetric concept only. Assuming a 30% slope for a 10,000 meter square plot, they later discovered this was incorrect. What is the approximate percentage underestimation of the true surface area compared to the planimetric area? Given the tan inverse 0.3 is 16.7 degree and cos of 16.7 degree is 0.957. So first tell me the actual area, what should be it? So first of all, tell me what will be the corresponding surface area. So planimetric area divided by cosine.
10,449, sir.
Okay, so and then this is the difference is 449. Okay, so difference is 449, like one is 10,000 and one is 10,449. So difference is 449 divided by 10,000. So you will get around 4.3% or 4.4% underestimation. So correct answer here is nearest option is option number A. Did you get or should I repeat again? So first find out the surface area, which will be 10,000 divided by 0.957. You will get 10,449. So the difference between the surface area and planimetric area is around 449. So 449 divided by 10,000. So you will get around 4.3% underestimation. Next one is
Is it divided by the 10,000 or 10,449, which is the surface area?
It should be, uh, yeah, it should be 10,450. Sorry, not the actual one, because compared to actual area, how much underestimation? So sorry, it should be 10,450. So we'll get exactly 4.3. So 449 divided by 10,449. So we'll get 4.3. Yeah, sorry. Thank you for pointing that out. Okay. So I think we did the last question or we missed it. Let me check it again. Yeah. So the last question was identifying the leeward and windward side of mountain range for a climate modeling requires a use of slope, aspect, vertical accuracy, or radiometric bit depth. So the answer is aspect. Okay. Any doubt till this point? So we've finished our question answer. Any doubt till this point? Okay, I think we do not have any question answer. So now we'll see some of the sites. So today we are going to see one site which is known as, let's say, um, let me, so the name of the site is Climate Engine. So this is specifically not GIS data, but it's more or less remote sensing data sets and some of the climate data as well. So if you are interested in doing some kind of how much rainfall is happening in your area or how much runoff is there, how much temperature is changing, you can use this site, or basically the data which you acquired through satellites to analyze that also you can use this thing. So after going through this site, you have to click on launch app. And then after you do the login using your ID, take some time to load. So then sign in using your mail ID. Mhm. The site will take some time to load. Okay. So we got this climateengine.org site. And then so this site gives two kind of view. One is map view and one is graph view. And this is a collaborative effort between DRI, University of California, UC Must, Google, NOAA, and these, and one more organization. So what does this site do specifically is, it has two tabs, make a map and make a graph. Now, what are these two is, okay. So first of all, make a map, it means it will show the output as a map. So here, first of all, select you want a raster or feature, basically raster summary or vector summary. So first, let's say raster. Now, let's say these are the various variables which are available within this. So here, if let's say we are interested in remote sensing data. Now you can select the satellites. So I am interested in, let's say, Sentinel-2 surface reflectance 10-meter data. and we can check the different indices such as vegetation index, bare soil index, SAVI, chlorophyll index, water index. Okay, so and just we can visualize the normal color image also. So I have selected the image. Now then after you go to the place where you are interested in looking in. So let's go to San Francisco and check the data. So then after here you select the processing. So what do you want to do? Mean, or like say if you have selected more number of days. So what operation you want to do to mosaic all the images. And I'm interested in the, let's say, last day of data, whenever this data is available recently, give me that data set. So you can check last year, last season, you can specify your custom dates as well, last year. But if you are providing more number of dates, then it will take some time to do the processing. And sometimes your area is, if it is too big, then it might not give answer also. So then after click on compute maps and wait for some time. Okay, the start date. So you can see now it is loading an image. I think it's similar to what you see the base map. So I think I will change the visualization so you will get to know. So this is a false color composite image of last 30 days. And you can see here, see what are the happening. And you can change the opacity also. So now I change the opacity. Similarly, instead of last 30 day, if I take the last December, January, February, or let's say last June, July, August. So this value for last June, July, August. So in this way, you can do the thing. If you have any mask, if you want to calculate for some particular value, you can mask also. And these are the remote sensing product. Then in addition to remote sensing, if you are interested in climate data, atmosphere data. So climate and hydrology is data like precipitation, temperature, evapotranspiration. So this CHURP satellite is there, ERFI is there, and everywhere you will see the spatial resolution and temporal resolution of the data set, at what is the size of individual pixel and how frequently the data is getting updated. So if we see the rainfall and all, this TerraClimate, which is a monthly data. So if we can see the precipitation in this TerraFike data, and then let's say we see last data, last month data. So this is available till 2024 only, and this is the larger grid. So you can see like this. So earlier product was at 10-meter resolution. This product is 5-kilometer resolution. So you can see the world data sets. And now going to India and just see the data sets. Now if you see these variations are not visible over India, then in that case what you can do is, so basically in the last month, basically December 2024, this much rainfall happened. And if we see the, let's say in one entire year, it's basically October to September, then it's a kind of 1 year data set. So it will look like this. In India, our water is different, but yeah, this is for just tentative idea. How does it look like? Then after, if you want to change color and all, so that also you can do. You can just go to map overlays. You can change the, if you can want to overlap something, you can do that thing as well. Any boundaries, world boundaries, or any grid lines if you want to add, or custom KML file if you have that you want to import here, that also you can do here. Apart from that, you can change the color pattern also. So color also you can change, its range also you can change. So let's say I will write it here 0 to 2000 mm. And if I will click on update map, it will update the entire map according to that. And you can see now the variations in India, we can see it very clearly that the regions in Western Ghats and the Northwest India, Northeast India, you can see a rainfall greater than 2000 mm, whereas in this part of Gujarat also we see the patch, here also we see the patch, and then overall this region receives around this much rainfall, which you can identify around roughly 1000 to 1500 in between. So this is the one of the data sets. Similarly, you can do it for various data sets if you are interested in jobs data, ERFI data. These are various data products. So if you are interested in anything, you can go and check it out. Similarly, this some datas, if you want to see about the temperature, then you can do the same thing. This is at 11 kilometer. So you can see the part in India, which part is hotter, which part is colder comparatively. And then here also the range is between minus 10 to 30. So if we are, let's say, specifying specifically over Gujarat, then I can see like temperature does not go less than 0. So what I can do is I can change the color map, and instead of this blue and red, if I want something which just show me the red color, so you can see the sequence color like all the red, and then I will write from 0 to 30, 0 to 30, let's say. So it's like most of the time it's going about 30. So we can change it accordingly. So this I already taught you in how to do it in QGIS. So I'll not get into that. But if you see here, like 0, it will not be there. Like always it should be 22 or 30 or something. So we'll just again change it a bit, 25 to 30. Okay, so now you can see the clear pattern, that which part are getting less than 25 and then more. So you can see here like this. So this red portion, like white portion, is having less than 25 degrees Celsius, whereas the rest of it, whereas if you see Thar, desert and all, they have greater than 25 degrees, 30 degrees Celsius also sometimes. So this kind of analysis you can carry out, and then the thing is whether you can download the data set from this site or not. So you can go to downloads and you can select a region because you cannot download it for the entire thing. So what you can do is you can just draw a rectangular region which you are interested in. So let's say I'm interested in this part. So you can just do it, and then after you go down and you can download the data at given resolution, or you can increase the resolution by 2 times, 4 times, and then you can change the file name also. And then if you want a PDF map format, then you can download in just map image, then it will download it fully. So this kind of thing you can do. Base map also, if you want, you can change. So this is all about how we can use this site for mapping purpose. The output will be in terms of map. Now, okay, this is the, let me show you the, so it will show you like this. So this kind of thing, if you are interested in little bit project or something which you are doing at your college, so you can add the data sets of this kind of tools, which will make your project very good compared to other. Now, coming to the make graph tab. So this tool will generate a time series. So it will generate the graph. So here, let's say we want to analyze some kind of polygon. Okay, and then we'll just remove this layer. Let's reset this. Okay. Yeah. So now coming to the make graph, and we'll use native time series, one variable or two variable. So right now we'll go with one variable. Then after we'll go to polygon. So you can go to point, polygon, or whatever data sets you are interested in. So now let's say, let me do one thing, that I will go to the near the area to my college and select some patches of agriculture area. Or so this one is a forest and these are the agriculture areas. So what I will do is, first of all, I will create a box here, and then let's see how much rainfall happens over this forest area. So basically, let's say I'll just increase the, yeah. So again, whatever database sets which we have seen, Terra climate, let's select Terra climate, precipitation, and let's give the custom range. So I want to give from January 2021 to December 2024. So basically in each month, how much rainfall is happening, it will show me that. So you will get this kind of analysis that it receives 66 mm in May, 81 in June, 222. So here also, if you will see in June, it is up 15, whereas here it was 81. So comparatively, this was a drought kind of year, because you can see it's very less amount of rainfall which has occurred during this time. And this might be a high rainfall years, because you can see 438 mm in a year. So that might be, so you can see the how much total rainfall occurred. So basically, and then after you can download this data sets also. So if you will click on download, you can download PNG, JPG, PDF, a vector file, or you can download the CSV and you can uh, put that thing and you can generate your own graphs using Python, MATLAB, or any other tool, or Excel basically. So this will download a CSV file like this. And statistics. So if you want to calculate the average value, running mean over, let's say like this. So running mean, average value, average rainfall. So this will be like that. And similarly, graph instead of bar, if you want to see as a line plot, it will show you like this. So you can do a lot of thing here. This is the scattered plot, line plot. So this is a very good thing which you can do here. A lot of customizations you can do here all the way. Uh, so then you can change the tick intervals also, minimum maximum values, and those things you can also change. Next thing is the similarly, now if I want to do the same analysis but for some different area, let's say. So instead of here, instead of one variable, I will select the two variable. Now first polygon is this, and there I want to evaluate precipitation only. Now I will take the second variable. Here also, let's say I'm interested in calculating a precipitation only. But instead of Gujarat, which is a semi-arid region, I will take a region where it rains a lot. So let's say take an example of, let's say, Goa, which is in the Western Ghat. So now I will make mm, another polygon here. So So let's say this is the another polygon which I have generated. Okay, so for variable 1, I have one polygon in Gujarat, and here I have another polygon. Okay, so variable 1, I will select over Gandhinagar. Okay, so for both, here I will just make sure that this also should be same. So January 2021 to December 2024 for both. Yeah. And then after I will just give in compute time series. So now you can see it gives me how much rainfall happened at both locations. I think I have given the same area in both. Okay, let me change it again. Variable 1, variable 2. Mm. So I think we can create one only. So I think there might be something which you can do for two. Okay, but corresponding, let's say now in one we can represent rainfall, and let's say in one we can show the, instead of precipitation, we see the minimum temperature. So you can see you can plot both things together, the minimum temperature and the rainfall also. Okay, so this way you can do the thing. You can plot more variable also. Afterward, so here native time series, then summary time series. Do summary time series, then it will do give the summary of it. So basically total precipitation, how much it is having, minimum temperature, how it is changing. Okay, so give you this kind of results. Deviation from, let's written 467. So basically how much deviation it has compared to the 467. So it has calculated the average rainfall, and then based on that which month it is a higher and which month it is a lesser. So it has done it for all the years and giving the summary of what happened in the area. Similarly, temperature also, if you see which year where has high temperature and in which year it was the cold temperature. So it has given the both the things specifically. So this is about the rainfall statistics, and this is about the temperature. So which year the temperature was above normal and which year the temperature was below normal. This kind of analysis also you can do. And the good thing is, yeah, you can upload your own polygon shapefile also if you have with you. So here you can just click on choose files, and then after you can go here and check on which file you want to upload, and then after you can upload the same here as well. And then after there is one more thing which is there. There is a third thing is two variable scatter plot. So when if we have two variables, and then I want to see the relationship between the two different things. So here, let's say we'll see the relationship between precipitation and let's say runoff. Runoff is means how much water is converting into the runoff. Rainfall is converting into runoff. So it's more basic that if rainfall is high, it will convert more runoff and vice versa. Just change the polygon, this area. So you can see if you are increasing rainfall, the runoff is increasing. But if it is increasing by this much, then there is a not much difference. Okay, so it's like if it is more, then it will become. But if it is small rainfall, then there is no effect on runoff. Similarly, here what you can do is you can consider the along with the rainfall, you can consider the vegetation. So how if the vegetation is increasing or not when you consider the rainfall. So basically, if irrigation is there, if we are doing the irrigation over area, then it might be not straightforward relationship. But the land where we do the irrigation, not with we just rain-fed regions, there it is highly dependent on rainfall. That if rainfall is high, crop production will be high. But land where we are doing the irrigation, when the rainfall is high, the irrigation like the crop is not that key, it will high or low only. Okay, so if it is less, then people do irrigation, and because of that also they will get more amount of crop yield. So that is all about this site. So I think you can make a good use of it and download the data and use it for your analysis. You can plot it further in Python and you can incorporate that into your reports as well. Uh, any doubt in this? Okay. Any doubt, anyone? So we have around 10-15 minutes are remaining. So I think what we can do is now I think we'll see one thing that there are a couple of things. First of all, some of the derivatives which we can uh, analyze. So now we'll go to the QGIS and do the study. Okay, so let me import some DEM first. Okay.
Can I ask something?
Yes, go ahead.
In this video, it was showing that we can derive some game from Landsat or such kind of satellite image, which is freely, which we can get it freely. So how to do that? What are the steps?
Okay, so I think good question. So I think we have covered that thing in the first class, but I will repeat it again. So there is a website known as Open Topography. Okay, you can go there and you can download the data. But are you asking about the DM data only or some other data sets?
So now I'm asking how to derive game from Landsat 8.
Okay, derive the DM from Landsat 8. Okay, so that is a good thing. So it will not give the direct DM, but there is a relationship like Landsat give us the thermal data. Okay, so thermal data is like how much elevation do we have now, like that is a 30-meter data. So the idea is that if you are going up, like if your elevation is increasing, what will happen to temperature? It will obviously reduce. Okay, so there is an inverse relationship between elevation and temperature. So based on that, they are calculating the elevation value considering this relationship. So main fundamental is this only. Based on this framework, they are finding. So you know the relationship. After that, you do something that like for the known point where you have the elevation data with you, or temperature with. You make a relationship between these two variable, and then after you can apply that thing for every layers. Okay, so basically it's on this concept.
Okay, sir.
Okay, so let me open any data related to the DEM. So I have opened this DEM. So what we'll do is first we'll try to generate let's say contour. So whatever we do, the first thing is convert this thing into a from degree to meter, and we'll see this currently it's in degree. If you don't know whether it's in degree or meter, you go to properties of that by right clicking on property, go to information and check the coordinate system. So current data set is WGS 4326, EPSG 4326, WGS 84, which is using latitude and longitude, and the units are in degree. So the problem with this thing is two units are in degree x and y, whereas z is in meter. So that's why if you do any calculation, either you have to use the z factor to make the units equal, or else you convert your data into meter first of all, and then you do the whatever you are interested in. So for raster, we'll do the reprojection using the warp tool. This is the DEM. Now sample source coordinate is W EPSG 4326 WGS 84. Target, if you don't know what target you want to keep in, so you just see your data. So this is starting from 80.878 to 81.14, and here from around 30 to 30.5. So now we'll see uh, predefined CRS, and let's say if we select the 43 north, then you see it's how much extent does it have. So if I see its extent, it's from 72 to 78 and 0 to 84. So 0 to 84 from 0 to 84 and 72 to 78 in the direction of longitude. So we are having from 80 to 81. So we cannot go with this one because it's from 72 to 78 only. So we'll do 44N. So now if you see, say it is from 78 to 84. So it is 78 to 84. So it is, yeah, it is within the window. So we will select 44 north. And then after, I will go back and then I'll just reproject it. So this is my reprojected DEM, mean 44 north. Now the thing is, I will calculate the contour of it. So for contour, I will select this contour tool. Now you select the reprojected DEM, then the contour interval between two contour lines. So here you can see our elevation is ranging from 2270 to 6887, which is quite high. If I select the 10-meter contour interval, it will give me a lots of lines. So better I can use a 100 or 200-meter contour interval. Even 100 will give me a lot of line, but I think we'll go with 200. So attribute name, its contours are for elevation only, so I will keep it elevation only. And then after I will run it. So you can see now I got a very good contours of my layers. Now how to visualize these contours or make it more meaningful to us. First of all, we will change the symbology of the given layer. Single band pseudo color, apply. Let's see how does it look like. I think it's fine. This we can 2300. So yeah, you can see now like this. Now I think contour also will change the color, make it black. Okay, so this looks good now. We'll add a layer of hillshade also at the back so that we can visualize it in 3D. And this Z factor, now we have all the things in meters, so we do not have to change it here. So this is the hillshade of the area. Now we'll keep the hillshade in the bottom, reduce the transparency of this layer. So now you can get the good sense of the DEM which you have. Again, if you think these contour lines are too messy, it's getting too highlighted, you can reduce its width or something like that, making it 0.2 like this. Okay, so it becomes very clear, and now like I can see a lot of things, very good thing, how the river is going, where what is how much it can expand when the rain comes, or the zones we can see it very clearly. Next thing is, let's say if in the contour, if you want to add labels and all, so you can go to contour and its property. So once you go to contours property, then you can click on labels, and then here you can click on single labels, and then you can select the like attribute which we have given, which is an elevation attribute, and based on that you can assign the uh, values. So you can see now you can see the values. Now if it is not visible, then you can generate the buffer around it. So basically it will become like this. So this will be more visible. Now where do you want to place the contours? If you want to add any mask behind, formatting if you want to do, then also you can do that thing. Text also you can change. Then the placement, so placement is parallel to contour line, out to the contour line, or on the line, below the line, what do you want to do? So let's say if you want to keep it parallel and on the line. Okay, so then you select on the line and click on apply. So it will keep contouring on the line, and then whatever the addition you want to do, you can do it, and depends on. So like this you can see. So I mean there are lots of things which are available which you can check. You can reduce the size of your text also so that it will not become this much. So basically you can keep it, or but all the changes you can do under this label tab. So currently I'm making it off, but if you're interested, or let's say keep it, remove the buffer, and the placement, we'll just keep it on the line. Okay. Now when you keep it on the line, it's better to give some buffer to make it differentiate, because otherwise it will be just crossing over. And this buffer size you can reduce if you want. Like this. So it will be more visible now. Now if you see this small box, it's a 340, 340. So you can see these variations very well now. Okay. So this is about contours. Now let's say if you are interested in cut and fill analysis or some other analysis, and we want to generate a raster that give me the all pixel values above uh, 3400, or let's say give me the pixel value about 6000. Let's say reprojected, give me the value greater than or equal to 6000, and then and this is 44 note only. So it will give me all the values. So now you can see it's all the values are located with the white color. I'm just interested in the white one only, not the black one. So I will make the other thing away. So for that, I will go to symbology. Now these are just two value only. So I can use the paletted and unique values. Now I can classify, it will just have 0 and 1. So 0, I will just remove it. 1, I will click key and I will make it red color so that it can give me a good visibility. So you can see I got all the areas. You can see it's bounded by the contour lines as well. So all the thing about the 6000, and I just keep this layer up down basically, and I can visualize within that also how much variations are happening. So I got all the values where the elevation is greater than 6000. It can be represented like this. And then you can see now, let's say if you want to create a restaurant or something at the top of the thing. So you first give this layer, then give the another layer that slope should be minimum, or it should have this much area. Then you can see the consider the total amount of area which is available. Therefore that you can see the connectedness with the pixel, because if you see these pixels which are very few, where you cannot, I think, construct something because the area is very less. On the other hand, these are the good point, having a larger area. So based on that, you can do the multiple criteria and do the analysis further. Apart from that, you can now check what aspect these cells have. As we discussed, as I discussed in the class, that if like lots of landslides happens in the southerly aspect, so you can remove that thing that it should not have. If you are interested in sky returns, then it should be on the northern part. So where to fix a base for this event? So it should have a northern aspect. So similar kind of things you can look into and do the thing, and then run the analysis and give finally find out some areas for any purpose, whether it's solar purpose, sky run purpose, wind installation, or any other renewable energy, or any other application considered regarding the infrastructure or any other thing. Okay, so I think this is the some of the analysis. Slope and aspect we have already seen in the previous classes, even the elevation profile and those things we have already seen. So considering what we discussed today, TPI and all. So if you are interested in doing so, so you can just take this tool, profile tool, and then just you can create a topography here. So I will just edit. So you can see now this is moving like this, and if you see here, it's like local slope is there. So here, if you consider this area, TPI might be 0. If you consider this, also then TPI will be greater than 0. And then if you consider all this to this much, then TPI will be less than 0, and it will show the valley. So this kind of thing you can see. Then further you can see whether the surface is concave or convex, how much it is looking from this cross section. You can compare the different cross section also, how it is changing if you're going from one location to another location. Then another thing is if you plot along the river, let's say like this, then you can see the overall slope of the river also. That I'm not going it in proper way, but keeping the So you can see the how river is behaving. So as you know that water flows from high elevation to low elevation areas. So you can go from high to low, the slope like upstream to downstream, the slope will decrease or elevation will decrease. So that you can see now if in particular stretch, if slope is too much, then there is a high chances of water getting like the surface getting eroded, and then in the subsequent part, the deposition can happen. So those kind of things you can visualize from this kind of figures. Okay, I think that's it. What I can discuss. Any questions, anyone? Any questions, anyone? Okay, so what we'll do is next. Now we are having two class remaining, and one we will discuss about the hydrological analysis, and one in general other analysis of this DEM derivatives. And in addition to that, I'm planning to give one extra lecture for this course where I think what I will do is I will collect the various questions which are asked in the gate examination from GIS section, and I will discuss that along with you. So I think that notification you will get in your NPTEL class also, but probably I will get this done, this class, extra class on 11th of April. So if you are interested, if you are applying for GATE Geomatics Engineering, please look for that particular lecture. That will be more helpful. In rest of two, we'll discuss the things from our class only, NPTEL class, on our regular classes during Tuesday. So hope you guys enjoyed today's session. Uh, with this, we'll end today's session. Thank you everyone for joining. If you have any questions, you can ask. Otherwise, we can close this meeting. Okay, so if there is no question, I think thank you everyone for joining, and bye bye. Good night.